Okay, so
Can I just formally introduce you for the PU students so they know who you are? Great. So Dr. Davis received her PhD in mathematics from Brown University in 2013 on the geometry of surfaces. She then did her postdocs at Northwestern University, followed by professorships at Williams College and Swarthmore College. Her research focuses on mathematical billiards and dynamical systems. Recently, Dr. Davis has been working with a group of students working on the problem of detecting and combating political gerrymandering and applying the same techniques to segregation in school districting. And then this will be the presentation that you'll be hearing about tonight from her students at Swarthmore, I believe, right? Mm-hmm.
yeah, awesome. I'll just give a brief introduction, which is that last summer, about 40 of us, you can see us in the picture, worked on this problem. We worked on 4 different states. And so we have, I think, 7 of us here tonight to tell you about it. So let's take it away.
So first to start, we just want to talk about congressional redistricting in general and how the seats are apportioned. So after the census every 10 years, congressional seats are reapportioned based on changes in population, and the people in power in each state redraw the maps. So this is particularly relevant now because it's a census year. So we just had the 2020 census this summer, and from the elections tomorrow, people that are elected for each state legislature will have the power to redraw the maps affecting people's representation. And then incumbent politicians, so people that are already in power, can increase their chances of reelection by gerrymandering, which we will look at next.
So what is gerrymandering? It's the manipulation of boundaries within state or congressional maps for purposes of partisan gain. Packing and cracking is one of the techniques used to dilute voting power of opponents. And this is where constituents are sometimes misrepresented and opposition is muted. So here we have an example. If you see the map all the way to the left, we have 60% Democrat, 40% Republican. But depending on how we split up this map, if we do a winner take all, here in the middle, you can see by splitting into 5 sections like this, we have 5 Democrats represented and 0 Republicans. But if all the way to the right, again, with the packing and cracking, we're packing all the Democrats in these 2 sections all the way to the right. And now Republicans take a 3-2 win, even though they're only 40%. So some scales of political geometry that are important to our research. The smallest scale we have here is a census block. And then we have census block groups, and there are about 39 blocks per census group. And most of the information, demographic information we get is from the American Community Survey. Next, we have precincts, and these are the most important to our research because this is where our voter data, this is like where we can get our voter data where it's public. And your precinct is basically like where you go to vote, and we do not split these. Then we have counties, and these are smaller geographic areas that have their own legislative power. We try to avoid splitting these, but it can happen when we try to even out population. And finally, we have congressional districts, and here to the right, we have 2 for New Hampshire.
So in doing our analysis, it's important to discuss what it means for districts to be fair. Partisan symmetry is one way that we can examine gerrymandering. Partisan symmetry is the principle that a particular vote share received by a party should translate into a specific number of seats, regardless of which party received that share of the vote. In the graph below, this shows that when Democrats receive 60% of the votes, they win 82% of the seats. And when Democrats receive 40% of the votes, they receive 18% of the seats. So partisan symmetry is met. In the 2016 election, when Donald Trump won the election despite losing the popular vote, the partisan symmetry standard was not met. Another measure of partisan fairness is the efficiency gap. This counts the number of votes that a party wastes in an election to measure whether one party had a systematic advantage in gaining seats through their votes. Any votes cast for a losing candidate are considered to be wasted, as are any votes that are cast for a winning candidate in excess of the number needed to win. The efficiency gap is quantified by convention as the total Democrat wasted vote minus the total Republican wasted vote divided by the total number of votes. This represents which party had an easier time converting their votes into seats. In this graph, the efficiency gap for many simulated districting plans for the 2014 state Senate election in New Hampshire is plotted, and the slightly negative average efficiency gap means that Republicans have a more difficult time converting their votes into seats. This also helps you quantify something that we already have an intuitive understanding of, which is that when I'm trying to decide whether I'd like to vote in my home state or in the state where I go to school, I'm trying to pick the place where my vote is least likely to be wasted. So I would want to vote in a place where the efficiency gap favored the party that I plan to vote for. Of course, the ideal, as with partisan symmetry, is that the efficiency gap is 0 and neither party has a tendency to have more of their votes go to waste. In order to create districts, we use GerryChain, which is a Python library created by MGGG. GerryChain uses a graph of the state in which each precinct is a node in the graph. You can think of it like a web where the intersections are the precincts and the lines between those represent that the precincts share a border. It then runs a Markov chain to create new districts that meet the constraints that we code in, such as compactness or wanting them to have roughly equal population, and stores each possible redistricting plan. Data from each of these plans can then be evaluated and compared to the current plan to measure its fairness. This GIF shows a collection of districts that were created by flipping boundaries between precincts in such a way that the population remained within 5% of the ideal population.
So our group was split into looking at a couple of different states, but we're going to start with New Hampshire. So the New Hampshire data was pretty accessible. The shapefiles were all stored on their statewide GIS clearinghouse, New Hampshire Granit. So we were able to pull those from there. And then all of their election data is stored on the Secretary of State website. So it was good that we were able to find all of this. It ended up being pretty time consuming to be able to actually organize all of the data so that we could use it. A lot of time consisted of just matching the precincts to the elections, and because some of them were reported by county, some were reported just by precinct alphabetically, and others were by congressional districts. So just having not everything in the uniform format meant that this took a decent amount of time. So we were able to export this and pair it with the shape files using Pandas, another Python library.
So this is a video of GerryChain's creating possible districting plans. This video starts with the districting plan that was created in 2011, and it's generating suggested plans for New Hampshire's 2 congressional districts. As opposed to the previous video, this one generates a new districting plan each time that's independent of the previous one, and it has constraints on its compactness, specifically on how many edges are cut when dividing the state into districts, where something that had more cut edges will usually visibly look more gerrymandered. Making these independent districts is much better for comparing to the current plan since they aren't related to each other in any way, and they are unbiased in their random nature.
Another thing we tried to do is restrict the amount of times counties were split. And we found that the current enacted New Hampshire plan has 5 county splits, but while drawing 1,000 random plans that minimize county splits, we found that 5 splits is actually in the 75th percentile. So it's very interesting that New Hampshire decided to be on the higher end of splits, and we're not necessarily sure why.
This is a box and whiskers plot of districts sorted by their Democratic vote share using the data from our ensemble of 1,000 simulated districting plans that we created in GerryChains. The red dot represents where the Democratic vote share for the current plan, which was created in 2011, falls compared to our simulated plans. We found that the median for the district with the lower Democratic vote share tended to be about 52% and about 54% for the district with the higher Democratic vote share. The current plan follows this median almost exactly, which means that this comparison does not imply any kind of gerrymandering was occurring when creating the 2011 plan.
We also looked at how many Republicans versus Democrats of the two representatives that New Hampshire has should be elected based on our data. So we ran 1,000 plans using the 2016 presidential election data, and it spit out these numbers here. So you can see, assuming everyone voted along party lines along how would they voted during this election, that the majority of the time, one Republican and one Democrat were elected. But these are the current representatives here, and you can see that 2 Democrats were elected in reality last election. Another thing about New Hampshire is independents have a lot of voting power. There's a large number of them, and running the Jerry Chain's code, lumping in the independents with either the Republicans or the Democrats completely changes the outcome of that for how many people from each party would be elected.
This is a weighted histogram of the vote share among precincts for the 2016 presidential election. So the height of the bars on this chart correspond to how many people lived in a precinct with that Democratic vote share. During this election, New Hampshire was skewed slightly Democratic. There are more people who live in Republican favoring precincts, but since there are more highly Democratic precincts than highly Republican precincts, it was overall blue. These heavily Democratic precincts create the potential for districts to be packed with Democratic voters more easily than they can gerrymanderers to create maps that benefit them.
Hello, everyone. I'm Katie, and I worked on the Maine team this summer, so I'll talk about our process a little bit. Next slide, please. Yeah, so our process was very similar to New Hampshire in the beginning. We gathered election data, precinct shapefiles, and demographics data, and it was all publicly available on Maine's government website. And in Maine, it was additionally easy because the precincts are the same as towns for the most part. So the bulk of the work was just looking for discrepancies in election data. Essentially, like, we had an issue whenever election data was reported for either a bigger or smaller area than exactly a town or a city. So in rural areas, there are a lot of townships that only had a handful of voters, and those handful of voters got reported differently from election to election. So we had to decide on a consistent town to group those voters with. And in big cities, election voting data was reported by split into wards or precincts. So we aggregated them to the city level. So at the end of the day, we had a consistent vote count for each town or city. Next slide. Yeah, and then we had to alter our shapefile to reflect the choices that we made about election reporting. So for all the townships that we roped in with nearby towns, we just had to make sure that the shapes matched that. So as you can see in the picture, that involved just a lot of combining squares into rectangles and L's. And then after that, we were able to join together the shapes, the election data, and the demographic data to begin analysis. Next slide. But yeah, we definitely ran into problems along the way, such as Moosehead Lake, which the issue was that it just doesn't touch anything, and that posed a lot of problems with the software we were using. But luckily, there were no registered voters on that small little island, so we removed it. Next slide. And then we were finally able to run Jerry Chain, and Dylan explained it before, but yeah, we just generate huge clusters of legally viable district maps. And then for each of those maps, we simulate an election and then collect the data, record the outcomes, and then we can compare the actual results in Maine elections to the average results over this ensemble of maps to make a case if there is or isn't partisan gerrymandering. Next slide. So that's the theory of how it's supposed to work, but in practice, in Maine, we weren't able to make a super strong case based on the simulated elections. As you can see, we produced these two graphs here, presidential election from 2012 and the Senate election from 2014, from the same cluster of maps. And you can see on the graph on the left that this data would give you the impression that it would be very difficult to draw a map that would elect a single Republican. But when we use the Senate data, it's the completely opposite picture. It makes it look like it would be impossible to elect a single Democrat to the House of Representatives. And we concluded that this shows more an issue in using voting history as a proxy for partisanship in Maine. So it's more an issue with the data rather than making a case for gerrymandering either way. And that makes even more sense when we look at the Senate race in 2014. Susan Collins, a Republican, has been in the incumbent for over 2 decades in Maine, and she has a lot of bipartisan support. But yeah, tomorrow she's in a very tight race against Sarah Gideon, a Democrat. So the incumbency bias might not be an issue for future analysis, but over the summer, we had to look at whether there was a different way of analyzing the data that didn't rely so much on the simulated election results. Next slide. So yeah, we decided to try and find a way to look at the average shape of where this line is drawn between the 2 districts in Maine over the whole cluster of maps. So how we did that was, if you see at the top, there's Madawaska, the northernmost precinct in Maine. And we just recorded how many times that precinct was roped in with District 1. So what we end up with is this map where the yellow region represents where the average line was drawn over the entire cluster of maps. And the black line shows you where the actual district boundaries are. So what we can see is in District 1, we have one representative, and in the other district, we have another. And they're both Democrats. So this possibly leads to the conclusion that there is what we call sweetheart gerrymandering for the incumbent representatives, because otherwise, if the line was where it is in the yellow, they would be in the same district running against each other. Next slide. Yeah, and we were able to also work with the group MGGG at Tufts in order to make our data available on District R, which is their tool to help kind of democratize this process of map making and understanding gerrymandering. And we'll be doing an activity with that later. Thank you so much.
Yeah, so just to sort of talk you through what we did as a Kansas group. So obviously a lot of the northeastern states had pretty centralized data. They were able to find one shapefile, one site. The state would have it, and then elections, one file, one site, and then start doing the process. But for Kansas, it was a lot less centralized. So they didn't have sort of a central repository of current data in the same way. So if we could move to the next slide. So a lot of what we had to do was essentially gathering this information, gathering the precinct boundaries from each of the counties into a single shapefile, single spatial geographic shapefile. So what we used was this format called an ESRI shapefile, which encodes you can encode a data table on top of a region, which essentially delineates a map drawn portion of sort of georeference data. So it has a spatial region, and then there's some data overlaid on top of it. And so our goal was to have a statewide precinct shapefile, as they've been describing. And we had to do that by getting county shapefiles from each of Kansas's 105 counties, merging them together, and then matching all of the precincts from the election returns that we got from the Secretary of State's website, making sure that they all lined up, because obviously we're getting these precinct shapefile county maps from different sources, and then put it all together into one sort of statewide file so that we could run the analysis on it. So you can move to the next slide. So obviously initial goal, get the statewide map of precincts. So the best source we started off with was the Tigerline file. So this was essentially the federal census, has one for every state. And this is done once every 10 years. So the most current one was 2010. We were working with 2012 election data. So the redistricting cycle finished in late 2011. So we wanted to see the impact of, what that was, how those lines were drawn in 2011 on the races in 2010. So obviously some of the district boundaries did change. So we wanted to be able to reflect that. So our strategy was to take older precincts and then match those precincts with recent election data. So we were basically matching by, we had this 10-digit unique identifier that goes with each precinct. And so we matched that identifier with the identifier for each precinct in the Tiger line data. And for each county that we were able to get an exact match, that was sort of a verification that there had not been a change made. And if it wasn't an exact match, then we figured, okay, well, there has been some change that's been made in the precincts since the last redistricting cycle. And so that warranted sort of follow up with the county. So if you can move to the next slide. So in order to get, so we got maybe sort of 40% of them had changed, 40% of the counties that had some changes in terms of what their precinct lines looked like since 2010. And so one of the big things we had to do is just sort of reach out to them and see what precinct data we could get. So county websites was a big place we got that. So, population, that allowed us to get, higher population counties tended to have better data. Having a GIS office was also a factor for success. So we were able to get some of them off of websites. You can move to the next slide. And then the rest of them, we just had to reach out by email. This is something that for a lot of data-driven projects where, if there's not necessarily a single central source that you're able to quickly analyze, you really just have to reach out on a pretty granular level and make sure you've gathered sort of each piece of data that you might need to conduct your analysis. So we reached out to the county clerk, the county appraiser, and then if the county had one, the GIS office and the cartographer with a pretty basic script. So if you can go to the next slide. So we were able to get pretty much all of the counties and we're sort of working on essentially working out any last kinks in the data. We were able to make an Excel tool that basically automated the checking of the county FIPS codes for each precinct against the election returns for that county. And so that speeded up the process a lot. And so generally we were able to get the data, the election data from the Kansas Secretary of State's office. And so then it was just a matter of, tracking down, okay, are there any mismatches between county FIPS codes in terms of the precincts themselves or the names? And then if there are, reaching out to them, see if any changes have been made, and then see whether we can sort of determine and track down what exact changes have been made, and then maybe digitize those from a PDF map, which I think we'll be talking about in the next section. But gathering data was for us one of the big challenges. So these are sort of the strategies that we employed. I think that's on to Nebraska now.
All right, so Team Nebraska, their names are listed here and none of them were able to be here tonight, so I'm going to tell you about it. So at the beginning of the talk, they told you about for New Hampshire, we could analyze the data and you could sort of see like what happened, but I just want to build on what Parker said, that like there's a ton of work that has to go on in the background to get the data to even begin to do the analysis. You might think that there's some sort of statewide shapefile everywhere, or there should be, but it isn't. It's county by county. So on the top is that colored map is what we got from Otoe County, Nebraska, is a PDF. And what we want is a shapefile. So a shapefile, as Parker was saying, is like a digital bunch of polygons that are associated with place in space. So we want to turn this basically piece of paper into some kind of a real map. So here is how we do it. So the picture on the right with the colors is the map that we got from them. It's like a JPEG or a PDF. And then we overlaid it on essentially a Google map. So that's what you can see in the background. And we have to do a projection. So it's like a mathematical idea to make sure that the points on our paper map match up exactly with the points on the Google map. And we usually do that by matching a couple of intersections, like road intersections or something like that, to each other. So you can imagine like a rectangle on the paper might end up looking like a slight trapezoid or something if the projection was a little bit different. So how do we do it? So on the bottom is the colored map that we got from the state overlaid onto census blocks. So Martina explained census blocks at the very beginning. It's the smallest level of political geometry. It's the level at which population is reported, and census blocks are apolitical. In cities, a census block is the same as a city block. You know what a city block is, and in the countryside, it's something else. Here, probably it's the 1-by-1 blocks that are so typical of the Midwest. So what we do is we overlay the picture map onto the shapefile that has the census blocks, and then we want to use that to create a shapefile of the precinct maps, each of these colored pieces. So what we do is we just look at the ones that are, say that upper left, that green precinct, that's a one voting precinct of Otoe County, and we simply take the union of all the census blocks in that green region, and then we name it by that precinct name. And then we go on to the next one, the orange one and then the blue one. And we do that for each of the voting precincts in Otoe County, Nebraska, and then we're done with Otoe County. And then we do that for each of the counties of Nebraska that doesn't have a shapefile. So the general workflow here is that we start with a PDF, like the one in the lower left, and then we start with census blocks like the upper left, and we merge the census blocks in order to get a shapefile that is the digital georeferenced map version of our original piece of paper. And the point here is that, my gosh, it's so much work just to get the data. The point is that when people vote, their votes are reported by precinct. So and any of you who vote, especially if you don't vote by absentee, you'll be reported in your precinct, and we just want to associate those votes to a particular geographic region. And that is why we need this shapefile.
So my little subgroup worked on something a little bit different. We examined prison gerrymandering in Pennsylvania specifically. So prison gerrymandering is the practice of counting incarcerated individuals as residents in the district of their correctional facilities instead of their actual place of residence. And this can impact the way in which voting districts are drawn and threaten vote dilution, especially because most prisoners are non-voters. And this can dramatically distort representation at the local level. So essentially, incarcerated individuals can inflate the population of certain areas without being able to actually vote in those areas. So if you put prisons in more rural or sparsely populated communities, you can artificially inflate the power of the voting members of those communities. And as Swarthmore students, we recognize that this is a particular problem for Philadelphia because it's very close by. And the prison gerrymandering practice is legal in all but 9 states. There have been several efforts to outlaw it in Pennsylvania, but they have failed. So we focused on Pennsylvania as Swarthmore students. All right, so we collected our data by contacting the Pennsylvania Department of Corrections and getting it all sent over. But unfortunately, the format is on an individual level, essentially. So we had to copy and paste thousands of like names and residences to collect all our data, which was very tedious. But once we'd collected the data, we ran Jerry chains on Pennsylvania, and essentially we ran it twice. Once with, as it is now, with gerrymandering, and once where we took the incarcerated individuals and artificially placed them back in their places of residence or where they would have, where their votes would have been counted. So this way we were able to create a graph comparing what the political climate looks like without prison gerrymandering and as it currently is with prison gerrymandering. So from those 2 runs, we developed this histogram, or 2 histograms, to compare the unadjusted and adjusted for the 203 House districts. This histogram here gives a little bit of a counterintuitive result because it looks like removing the gerrymandering takes seats away from Democrats, which is opposite a 2018 study that found that prison gerrymandering typically inflates Republican votes. But we suspect that this is because when we ran Jerry chain, we only were able to do about 1,000 iterations. And since then, we've been able to run 10,000 iterations, and that gave us a result that was far more similar to what we expected, where it took seats away from Republicans instead of Democrats. So we hope to run more iterations in the future and continue to examine the data. So some of our goals and next steps, we've just reached out to Brian Cannon, who belongs to One Virginia 2021, which is an organization focused on legislative efforts to end gerrymandering in Virginia. And Virginia is the newest state to pass legislation which bans prison gerrymandering. So we were hoping to get advice on pushing some of these time-sensitive bills like House Bill 940, which is a bill to ban prison gerrymandering, ahead of the census publication. And we also wanted advice with supporting Pennsylvania General Assembly representatives like Joanna McClinton in their relevant policy proposals. And this can take the form of contacting local newspapers or political organizations to get more coverage and advocacy.
All right, so we've told you all about collecting the data, and now I'm going to show you what we can do with it. So the purpose of collecting that data was so that we could analyze districts. So there's this website called districtor.org, which I'm going to encourage you to use. So I'll pop it into the chat so that you can start looking at it. And while you do, I'll tell you what we do with it. So one thing you can do in Districtor is you can put a data layer so that you can see the partisan lean of various precincts. So that's the left picture. You can see some of the precincts lean red and some of them lean blue, Republican and Democratic. Another thing you can do is you could pick up a paintbrush and draw your own districts. So I've done that in the picture in the middle. And then you can analyze your districts. So that's the overlay on the right is districts with partisan lean. And then the last slide is, so here's your task, should you wish to accept it, is to make 2 districts in Maine. You can do any state you want. You'll see that there's a big bunch of them, but click on Maine and then click that you want to make 2 congressional districts out of precincts. Here, and then here's your goal. So you want to make 2 districts who have the same population. You can see that on the ones that I made here, I was able to have a maximum population deviation of less than 1%, which is pretty good. And then if you would, you might choose, we want to have, so you can look at different partisan, then you can analyze your districts in terms of partisan balance, like who wins. So if you make 2 equal population districts, you can pretend that they're for the US House of Representatives, which are the ones that are elected in those districts. So use the 2016 data perhaps. And one thing you could try is to gerrymander. So you can see in the lower right corner of this slide that the overall vote share in Maine is 51.83% Democratic and just under 50% Republican. If you make two districts, just 2 random districts, you'll find that usually one of them is like maybe 54% Democratic and the other one is like maybe 54% Republican. It's pretty hard to get 2 of them over 50% Democratic, but you could pretend to be a gerrymanderer, and this is your quest, so you choose to accept it. So I'm going to switch to sharing the screen. Hope that's okay. Yep, I'm going to do it. So if y'all could follow along with me, I'm going to go to districtor.org. So I put the link in the chat, but you can go to districtor.org and then click on Start Drawing Districts. You can click on any state you want, but we love Maine the most because we collected the data for it. And then you have a bunch of choices. Let's click on Maine, 2 congressional districts built out of precincts. So I hope you all are doing this, and we'd love to see the districts that you make. So grab the paintbrush, it's up in the upper right corner, and you have 2 colors, blue and yellow. I suggest whatever district is in the lower left corner, I suggest you make that one blue because it's going to be the more Democratic one, and then it's not confusing. And you can use the paintbrush. So here you can see on the right, our population is growing. Check that out. I take the entire top part of Maine, and it's only got 73,000 people. Anyway, the point is to make 2 districts and try to make them equal population, and then see what their partisan lean is. You see, I lose. Okay, and then if we do this, I can maybe get 2 districts that have the same population. That's pretty good. Yeah, okay, so now I've gotten only 0.24% population deviation, and then you can evaluate your plan over here. So the race information isn't too interesting for Maine. Unfortunately, it's mostly white. And as now here, this defaults to the US Senate election. As Katie pointed out, that's the election with Susan Collins. So Maine goes really Republican. So let's try something like 2016 US House. So you'll see my District 1, 56% Democratic. My District 2, that's the yellow one, 52% Republican. So your quest, but they're equally population. So your quest, should you choose to accept it, I hope you will, is to make equal population districts, but elect 2 Democrats. Okay, and yeah, so please do that and report out. Go.